Good morning, everybody. Good morning, everybody. My name is Okoro Christopher, and my aim today is the introduction to this. Before we start, I know there are different definitions to DevOps. Different people have different meaning of DevOps. If I ask everybody here now, I'm pretty sure everybody will give me a different answer. But most times, what's DevOps? They don't actually give you the true meaning because most people don't know what DevOps is all about. So before into the KD, I'll be talking on a few highlights, traditional methods, which are methods before the introduction of DevOps, what DevOps is, the true definition of DevOps, the DevOps cycle and phases, the DevOps tools, the DevOps process, and advantages of DevOps. The traditional method, before DevOps, there are two traditional methods, which is the waterfall model and the agile model. The waterfall model is like a legacy model, it's still being used, even though it's not mainly used in the IT world like that. It's not advised to be used in the IT world. It's still used in your everyday life. You use the waterfall model in most of your projects that you undergo. And the agile model is like the main one that people do. And we are trying to adopt the DevOps method from that. First, the waterfall model. The waterfall model has a step. If you check online or through the slides, you can see the slides, you see that the arrangement of the steps are in a slopey form. From the analysis to the requirements, to the specification, to the design, the development, the testing, and the maintenance. It's like a slope. So the order has to come from up. Any mistake during the order, you have to go back to the top. And that's, let me start by explaining the different steps. In the analysis model, in the analysis stage rather, you meet with the client, you discuss what the client wants, is a website, a software, is an app, whatever this client wants you to do for him, the requirements. This is between the client and the developer. The developer gives the client the requirements. Okay, this is what I need to do. This is the program I will use. If the client gives a go, they move to specification, which is basically the type of product you are giving to the client, how the product has to look like, or the industry or the company that you are doing the product for, or the users you are trying to meet up with. Then next step is the design. Design, you give like a model, or how would I put it? Like, what's it called? Like a plan of how the design is going to look like a sketch, is a building like a sketch, a rough work of how the model is going to look like. Then the next step is development. Develop the tool, use an app, you code, website, whatever you have to do to develop the tool. Then you build the tool from there. The development stage involves the coding and the building. Then the next step is the testing. This is where the client comes back. You test the tool in front of the client. It is okay with the tool, or the product rather. It's okay with the product. Then you move on to maintenance. The problem with the waterfall models, within these steps, you have to pass one before you get to the other one. So the analysis has to be correct before you go to requirement. You cannot jump from analysis and skip requirement to specification. You have to go each step. And during the design process, if the client comes back and it's like, maybe you are building an app, and let me say the base color of your app is, let me say, green or something, like, let me use that. Let me say green, and the client comes out and it's like, I don't like green, I want red. You have to go back to the analysis. You cannot infuse green at that design stage. You have to start all over at the step from the beginning. As I say, waterfall model, water comes down. You cannot take water up back. It comes down. So any disruption within the steps, you have to go back to the top. And if the client is not happy at the testing stage, you have to restart the whole process. So that's the major issue with the waterfall model, that the clients and the developer, they are not usually in line. The developer does not usually understand fully what the client wants, and human wants are uncertain. So definitely the client is going to come back and is going to have some specifications that he needs, or some new features that he needs to be added to the product. The next model is the agile model. This is a very common model used in most IT companies, even as at now, as at today, the agile model is being used. It's like the base for the DevOps model. The agile model has like, it's a process too, but there's a difference between the agile model and the waterfall model. The first step is the project initiation. The client meets with the developer. The developer gives the client the specification, the analysis. The client tells the developer what he wants and all that. The developer takes the specification and the analysis that he has gotten from the client. He goes into the design phase, does the design, implements the design, test what he has, the product he has done, then there's an evaluation. The good part of agile, the good thing about agile compared to the waterfall models, there's a process called a sprint. This analysis, design, implementation, testing, and evaluation has to be done in a sprint. So the client has to come back at least like 3 times during the process so that you can review whatever you have done to him, so that he can make his corrections, tell you what he wants, what he does not like about the project. And within these sprints, you are supposed to do at least a minimum of 3 sprints during any production. So the project you are going to do, you are going to review 3 times before you can move on to the deployment stage, which is the testing on live or the uploading of the website. Advantages of agile: the class requirements are better understood, just like what I said. Due to the fact that you have to run at least 3 sprints of the testing, the design, the implementation, and the review for the clients, chances are within that 3 sprints, you are going to have covered whatever the client wants you to do. You have done exactly what he wants to do about the products rather. The product delivery is much faster compared to the waterfall model due to the fact that you have to run the sprint and most of the processes here can be done automatically. You can use tools, you can automate compared to the waterfall model where only one person, and in the agile model there can be developers team and the operations team. But in the waterfall model, likely is only one person. Only one person doing the waterfall model. You don't pass the design to another person. It's one person. Because only one person that meets the client, only one person that understands whatever the project is about. But in the agile model, they can be teams. After the developers are done with the sprints and the flares, the disadvantages of agile: the product gets tested only on the developer's computer and not on the production system. Since there are 2 teams involved, the developers team and the operations team, once the product is moved from the developers server to the operation server, chances are dependencies on the 2 servers might not be the same, and the product might crash or have some issues with production server. And most times, since the production guys or the operation guys are not involved when the client comes with the analysis and the requirements, they have no clue on what the product is supposed to do. So whenever the product breaks down from, you have to take it back, have to consume more time. The second disadvantage are the operations team. They are not in sync. So operations team only knows what is going on when the developers bring the product to them to deploy. The last one, if the product fails in the production server, the production team is clueless and sends the product back to the development. Development team already made explanation of that. Once the product breaks in the operations server, they cannot do anything because they don't know what the project is about. Their only focus at that stage is to deploy the product, test if it's good and deploy it. And if it breaks down there, they don't know how it was built, they don't know it was used. They just have to send it back to the developers team. Now we move to DevOps. DevOps is like an upgrade from the Agile model, not the waterfall model rather. So it's an upgrade from the Agile model. Since the Agile model understands the client and the developers and the clients understand themselves better, they just upgraded the sync between the developers and the operations team rather. What's DevOps? DevOps is not a skill like most people think. You see at somebody and you call him, this guy is a DevOps engineer, and it's just a title. DevOps is not a skill. You cannot go to school and learn DevOps. DevOps is not a tool. You cannot say because I know how to use Jenkins or Git or whatever tools is in the DevOps cycle, and you say you are a DevOps guy. DevOps is not a tool. DevOps is rather a strategy or a methodology, just like the waterfall model. You cannot be a waterfall guy. You can only use the process. It's just a methodology, the DevOps involves three stages of conversation, which is the people, the process, and the products. What I mean by this is for you to agree that this company or this process you are doing is DevOps process, three things must be there. There are three major requirements. The people, different things must be involved, and they must work in sync. If the things are not working together and you are using the tools and you are following the process, that's not DevOps. The process, you have to follow the process accordingly. If you are using if the different things are working together, you are using the tools, but the process is not going the way the DevOps process is supposed to be going, you are not doing DevOps. And last, the products. You might not be using the product. If you are not using the product rather, but the people, your teams, your operation teams, your development team, your QA team, they are working together, they are in sync, but they are not using the DevOps tools. That's not DevOps. And even if they are following the process, that's not still DevOps. Definition of DevOps. DevOps is a culture or practice which promotes the collaboration between teams to make production faster in an automated manner. DevOps cycle and the phase. One of the major points of DevOps is automation. It has to be automated. Most of your practice has to be automated. Each phase has to be automated so that it will be faster. The main aim of DevOps is to be faster than the Agile model. It's not like the Agile model is bad, just to improve on the Agile model. So it has to be faster than the Agile model. The DevOps cycle is like an infinity sign. It's a continuous process. You don't get to the end and you're like, it's over. I have no problem with the product again. It's out of my hand. The DevOps cycle is a continuous process. So if you are to build a project, you have to monitor it, the upgrade and everything is on you. Whatever teams are involved, whatever involves the new features of the app or the product is on those teams. They cannot at one point drop it. Once they drop it, they are no longer following the DevOps process. The first stage or the first phase of the DevOps cycle rather, is the plan phase. The plan phase, this involves the client and the developers, just as every product initiation has to start. The client has to meet the developer, the user, or whoever needs the product has to meet the developers, tell him or her what he needs. The next stage is the coding stage. This is still on the developer's team. The programmers design and code the application using tools like Git to store the application. Most of our programmers here use Git already, so we are familiar with how the Git works. Build. The next phase is build. Tools like Maven, they collect codes from different repositories and combine them together. They actually combine different codes from different containers and combine them to build the actual software that you are going on the website that you want to build. Combines different codes from different developers, because most times when you are doing a large project, it's not mainly one developer that is working on that project. There are different teams coding, and that's why Git is advised to use, because it enables versioning, so different codes can be in sync together. And Maven is a tool that you can use to collect those codes from different programmers and build up the entire project or the entire product. The next stage is the test stage. When the product is built, use a tool like Selenium to test the product, whether it's working fine, whether there are any errors. Selenium sends you like a log, so you check where the fault is coming from. You make corrections. This is still on the developer side. Then the next stage is the release or integrate. When you've tested the product and it's fine, you deploy the product. Next stage is deployment. You use tools like Docker. I think on Wednesday, Smith was talking on Docker, how Docker enables you to use container to move an application from one server to another server without the problem of dependencies. Docker is not the only tool used for this deployment, but Docker is like one of the major tools, because Docker, one of the problems we have with the operation and development team is that they use different servers. Most times they use different servers. So when the product is moved from the operations team or from the developers team to the operations team, there might be plugins that are missing, dependencies that are not there. But when you use a tool like Docker, it moves the product the way it is on the developers team to the operations team. So there's no issue of dependency, there's no plugin, or there are no system requirements met met on the this thing on the developers or the operations server rather. The next stage is the operation stage. Once the software is deployed, the operations team perform activities like configuring servers and provisioning them with required resources. Docker can also do this process. Once you move the product from the developer's server to the operation server, Docker has already done the issue of configuring the server so that the application will work properly or the software will work properly or whatever products you are releasing work properly. The last stage rather is the monitor stage. The monitoring allows the organization to identify specific issues or specific release and understand the impact on the end users. We use tools like Lagos in this process or in this phase to monitor whatever products you are releasing, whatever product you are deploying. Lagos is very common. It monitors websites, apps, whatever you need to monitor. Lagos is the tool for it. Move on to DevOps tools. If you can look at the slides, you will see the diagram, the plan, the code, the test, the integration, the deploy, the operation, and the monitoring stage. Each of these stages have a tool that is responsible that you can use to automate those stages. Though you have to code, definitely you have to write the code yourself, but the rest, the testing, the deployment, you can do that automatically with the help of these tools. The planning and the coding stage, you can use Git, you can use Subvision, you can use Jira. The build stage, you can use Maven, you can use Cradle, you can use Army Ants or Apache Ants rather. The next stage which is test, you can use Selenium and you can use JUnit. The integration stage, you can use Jenkins. Jenkins is like the most popular one in this stage. You can use Jenkins, you can use Bamboo, and you can use Hudson. The next stage is the deployment stage. Talk of that, you can use Docker, there's Vagrant, there's Puppet, there's Chef, SourceStack, Ansible. Whatever tool you can use to automate this process. Now, the monitoring stage, you can use Splunk, and Nagios. Nagios is the most popular one in this. The next is the DevOps process. Another major thing in the DevOps process is continuous integration and continuous development. That has to happen. The DevOps process has to allow continuous integration. Whatever new feature you are bringing into the product, whatever whenever the client comes in, even if you are at the build stage and he brings in a new feature, you should be able to integrate it into the software or the product you are releasing. And Jenkins is one of the major tools for this. In Jenkins, you can version your this thing. Jenkins, if you code a new, let me say you are coding a web, let me say you are building a website rather, and you build an original website. There's the main one, the version one, and the clients come back and it's like, okay, I need this to be added in the website. You can version it, build another one, or use the code base of the previous one and just change the features in Jenkins, and Jenkins will just version it, test it for you using Selenium, because Jenkins integrates these two together with itself. Test it using Selenium. If the build is good, send this to Docker or to the deployment stage or to the operations teams for them to deploy it. The continuous delivery, the planning, the coding, the building, and the testing, you have to be prepared to do that all over again. Since you are using automated since you're using automation rather, it should be easier. The planning, the coding, the building and the testing, since you are automating it, it should be easier for you to do. So you should be prepared to do that whenever the needs arise. Release, just like I said, Jenkins, it helps you integrate versions. You can build new versions and deploy new versions almost immediately. The next one is continuous deployment. You have to be ready to deploy. You have to be ready to deploy new versions as the client wants. Any new feature that is added, you need to be ready to deploy it immediately. And this is done at the deployment and the monitoring stage. Since they are automated, the time taken to develop and reduce and deliver software is reduced compared to the agile model. Since every process you are doing is automated, it's faster than the agile model. And since anytime that the clients come, you don't have to go back to a starting point, you don't have to restart. It's faster, higher quality, and fewer bugs. Since you are using apps like Selenium during the build stage or during the testing stage, rather, any error will be detected by Selenium and you'll be able to correct it at that moment, even before it gets to life. The next one is complexity of maintaining a product is also reduced. You're automating every process. Each of these tools you can have on one server. Each of these tools you can have on one server. You can have most of these tools, you can have them in-house too. Jenkins you can have in-house, Docker you can have in-house on your system. So it's easier for you to do all this process compared to the agile model where you have to move from one server to another server, from one person to another person. Improve collaboration between teams. The main aim of the DevOps process is to improve collaboration between teams. Development team and the operation teams have to work together. They have to be in sync. Whatever the development team is doing, the operation teams have to be aware. Next one is continuous integration and continuous delivery. Ensure faster time of product to market. Due to the fact that you are prepared for continuous integration, any new feature that is added, you are ready to integrate it and deploy immediately. Your product is released faster to the market, so it gets faster to the market better than the agile model. Questions? Any question? Yes. I said deployment. Can I share more light on it? Okay. Uh, Let me use like a tailoring company. Let me take it out of IT so that I should do something with our. Imagine if a client comes into a tailoring company and he gives you a design of what of let me say trouser, the specification, the weight, whatever measurement you need. Once the developer has gotten this, let me say the tailor has gotten this, he takes it to his machine or builds or creates the clothes. In the agile model, once he creates the clothes, he calls the client back. Like, okay, I'm done with this clothes. Come and test it. If the client tests it, if there's a problem, goes back, checks the measurement, anything he needs to do, any new feature that the client has added, does it. If it's true with that, he calls the client again. He tells him, okay, I'm done with this, come back. If the client is okay with it, goes back, checks it, then he moves it to, let me say, the models that will test it, then send it back to the clients, something like that. In an IT world, let me use an IT world. If let me say they're asked to build a website, and let me say a hello world website, just it's a website I'm sure in hello world. If the developers understood what the client wants, just an hello world website. He goes, he builds the website, it's written hello world. The client comes back, he calls the client after the first sprint. As I said, you have to have at least a minimum of 3 sprints. The client has to come to the company at least 4 times, which is the requirements time, the first sprint, second sprint, and the third sprint before you deploy. So once the client comes to the company, he sees the hello world like, okay, I don't like the font. That's the first sprint. Goes back, he changes the font. If the client comes back and like, okay, I need an exclamation at the end of my hello world. That's the second sprint. So it's believed that before the third sprint, you have understood what the client wants and be ready for deployment. Any other question? Okay, before you go.